Hello everyone, my name is Dr. Himmat Alisha. Welcome to the series of H-Rank NLP project. This is our part 5 where we apply counting the frequency of the words. Then we apply the POS tagger, parts of speech tagger, where we separate candidate words into the nouns, adjectives, and verbs. Then we apply normalization using stemming and lemmatization. So please keep watching part 5 of our series H-Rank Keyword Extraction for Web Pages. Yes, so we last time we just mm, saved the candidate words as a pickle file. Let's see what were the candidate words. Part 3 we learn about the candidate words. The candidate words are the words, those are becoming possible keywords for the web pages. So in this video, we will learn mm, topic count frequency is what we learn number 1. So step number 5. In this step, we are going to learn count frequencies of the frequency words. Next, we are going to learn is POS tagger, parts of speech tagger. Okay, so yes, so first of all, we need to import package is called here was the import counter. Yes. From collections, import default dictionary and counter. So we need to import that one. So now we need to count the word counter equals to counter and candidate words. Yes. Let's see what. So we can see each word ago appears 65 times. This works as an object. HR and the US BBC appear 25 times. So let's make this word counter as a dictionary. Word counter to okay. And now we check word counter. So now we have a dictionary file word with how many times each word appears. Another way to go one by one word is like from the counter, for example, bar, word, and FR in word counter dot most common. Maybe we say 10 words. Print word and frequency. Okay. So let's see. Yeah, you can see top 10 keywords. If we remove the word, it will display all of them. So this is the way how we can display those words. Next, we learn about the parts of a speech trigger. Now we have a dictionary of the word, a word, and a complete how many times a word appears, the frequency of those words. Next, we learn POS part, trigger part of that. Okay, now so we change candidate keywords to the different part of a speech trigger. Here in our keyword extraction, we use three part of a speech trigger: nouns, adjectives, and verbs. So first of all, we need to import text blob because we need to convert the candidate words into text blob because we will use the text blob POS triggers. So we say this from text blob import text blob. Okay. Then we say we need different tags, for example. So first we create nouns, comma, adjectives, comma, verbs equals to blank list. And we are going to append the three different candidate list. Then we need to have tags names for nouns. Noun tags, we said that equals to, we say NNS, NN, then we have this NNS, and third and fourth, NNP, NNP, and then we have NNPS. Proper noun, P is proper noun, and then we have same adjective takes equals to, I know this very famous JJ and JJR. Then we have JJS adjectives. Then we have verbs. Verb text equals to three, four, comma five. Okay, so first of all, we have VB, then we have VB, VBD, VBJ, VBN, VBB, VBB, and then we have VBZ, VBZ. Now we say for word in candidate words. For example, let's see what it's word inside. So we can see we have these all candidate words. Now we change these words into the blobs. So we say blob equals to word text blob. Then we say this word. Let's print blob. So now these words, candidate words, become blob. So we say now we get the tags of the words blob dot text print text. Let's see. So we can see now we have the word and their take. For example, BB is noun, home is noun, breaking is BBG verb. So we have all the words with their POS take given on the side. So we need to separate nouns, adjective, and verb. If we say if, now we just need to go through loop for word, comma, take, in, taked, if, take, in, noun, takes, then noun, we have already noun as a list, nouns, dot append word inside. If take in adjective tags, then we have adjective list append word. Then we say if take in verb take verb dot append. What we append is a word. Okay, let's print all of those lists now. Print nouns. So we will verb take. Verb take is not the verb. Verb take. Verb takes, sorry. Store verb takes now. So now we can see all the nouns as a candidate word. Now we can see adjective. So we have adjectives and same is verb. Okay, so let's make this as a function now. So we say these here, control X, define POS separator. We need candidate words from up, and we need these verb list, and then we need to return nouns, adjectives, comma, of. Okay, we can also define these here. If we call these nouns, adjectives, comma, verb equals to these, so we can print nouns. Okay. Okay, after POS separation, we do normalization. Basically, normalization is a process of making words, candidate words, into normal form or base form, first form. Stemming and lemmatization is used for the normalization purposes. Stemming chop off the word from the end of the word, and lemmatization look in the dictionary. Stemming is faster while lemmatization is slower because lemmatization requires a dictionary. So let's see both of them. First of all, we need to import. Uh, First of all, from we say nltk.stem import porter, sorry, porter stemmer, comma, we need word nate Lemmatizer. So we say stemmer equals to porter stemmer. Initialize the porter stemmer and the lemma equals to word Nate lemma initialize it. After that, from nltk dot stem dot corpus import wordnet. So we first import these things. Then let's see the example how these things looks like. I just put one example, copy paste it from here, apply these things. Let's see the example. We have, for example, nouns, adjectives, and verbs. Three lists here. Beautiful dogs, played, cities, and adjectives and verbs. So stem words would be run happily, beautiful dog, play, bitter, city. So you can see stem is chopping the words. From cities, it's city. It's a wrong word. So stemming basically chop the words from the end of the word. But lemmatization, you can see cities become city, which is correct. And happily becomes happily is correct also. But here in stemming, we see happily. And beautiful becomes beauty. Dogs become dog. It's okay. And played become play. Stemming is okay. And dog becomes dog in lemmatization. So lemmatization is much better but slower than the stemming. But we perform both of them here to see how these works. So we have initialized port stemmer and lemmatizer. Now let's see how we apply on our three of the list, candidate list. We have nouns, we have adjectives and verbs. So first of all, for example, for word in, for example, we say nouns here, and then we say stemmed word equals to stemmer dot stem, and we say word. Same way we have lemmatizer, lemmatize equals to, we have lemmatizer dot lemmatize, we say word. But let's put these in the list. We say stemmed words. This one, and we say lemmatized words equals to list. Now we append both of the words. Stem words dot append, not to words but word. Okay, and then we say this one. We say dot append this one again. So let's see how these lemmatized words looks like. Okay, so now we have lemmatized words as a candidate word, and we can also see the stemmed words. Let's see. Now we have stem and lemmatization. So in this video, we have covered parts of speech tagging, stemming, lemmatization. In the next video, we will see how we can utilize these candidate words, stemmed and lemmatized words as a candidate word for the clustering, and finally we get the keywords for after the clustering. Thank you for watching.